Hey everyone. So we're moving into our 19C section about clouds and precipitation. So today I just wanted to talk to you a little bit about cloud formation and how that happens. We learned in chapter 2, if you remember, that water can be in solid, liquid, or gas form in the atmosphere. When it's liquid water or ice, then it often forms clouds. Okay, for cloud formation, we have to talk about the humidity factor. So, warmer air allows for more water to evaporate than is condensed. So, if the air is warmer, it's easier for water to evaporate. So, if we have this warm air and a lot of water evaporates, and then the air begins to cool, then eventually the rate of evaporation will be the same as the rate of condensation. Once we get to that point, that's called the dew point. That's where relative humidity is at 100%. And if you remember relative humidity, that's where those air molecules are holding all of the water that they possibly can before they have to get rid of some of it. So that's where we're at the dew point, okay? So if that air continues to cool, then we're going to have a cloud that forms, which we'll talk about here in a second. Okay, a cloud is a mass of extremely tiny liquid water droplets or ice crystals in the air. So there's this area that has a lot of liquid water or ice in it. All right, for clouds to form, the temperature of the air in that section has to be at or below the dew point. Okay, how does this happen? So let's say we have this warmer air and this water evaporates, and then it starts to cool down, but not quite enough for this cloud to form. Okay, well, as the air goes up in the troposphere, which is where all of this happens, then it cools off because the temperature drops as we head up higher. Okay, so as this air is forced upward, it starts to cool. Well, then it gets to the point where it's holding all of the water that it can, and then it cools off more and it has to get rid of some of that water. Although that can happen without the presence of condensation nuclei, it's harder for it to happen without it. So condensation nuclei are just these tiny particles in the air that easily attract water molecules. So like dust or pollen or even smoke. If there are these particles in the air, then once we reach the dew point or even cooler than that, then these tiny water molecules easily are attracted to these pieces of dust or pollen or smoke or whatever this condensation nuclei happens to be. So as they all come together, they start to form these bigger droplets. Freezing nuclei is if the dew point is below freezing, then the water vapor deposits as ice crystals on the particles instead of depositing as water. Okay, moving on to this next slide here, super cool clouds. I'm not going to spend a lot of time talking about this, but there are times when there can still be liquid water in these clouds, even below the freezing point. And if that happens, then any small little disturbance can cause it to quickly become ice. So that's what it means at the bottom here when it says these clouds are unstable. So any little movement that comes in the area can cause all of these water droplets to form to ice very quickly. All right, so that's a little intro to how clouds form. I realize you may need to read or listen to this video again. Please watch the videos that I've posted with this because they're really helpful so that you don't get confused. We're going to talk about types of clouds closer to the end of the week, and that's just something you'll have to go over a few times and kind of memorize. And then we'll talk about types of precipitation on Wednesday. So if you guys have any questions, please don't hesitate to contact me. I'm here to help. I miss all of you, and